Hi, this is Adam from the classroom. In this video, we'll be discussing division. So at first, we need to recognize division as the opposite of multiplication. So when we consider multiplication as continuous addition, division is counting in continuous subtraction. Let's see what this looks like. With this example, 6 divided by 2, we need to subtract 2 from this number until it's 0, or the answer will give us a negative. So we subtract 2 from 6 to give us 4, we do it again to give us 2, and we do it one more time to give us 0. We've subtracted a total of 3 times, so that means that our answer for 6 divided by 2 is 3. Let's do one more example. 13 divided by 6. So we know that we need to subtract 6 from 13. We subtract it once, we get 7. We can subtract it again, so when we do so, we get 1. Now, if we subtract 6 again, we'll get a negative. So that means we should stop. We've subtracted a total of 2 times, and what's left after that is 1. So our answer is 2 remainder 1. Now, division is done very differently compared to the other 4 operations we've already learnt of. The simplest form of division is done as we saw previously, with continuous subtraction and counting the number of times you've done that. But the easiest way to answer division questions is by knowing your multiplication tables. You can take multiplication tables as shown here and shuffle them to get the basic division. We can see that the first 2 numbers switch with the number on the right. We can remember this generalization. ABC becomes CAB. This can help us change multiplications into divisions moving forward when we're looking at more advanced questions. Now, solving division questions is most often done using the method known as long division. This is done by taking a question and presenting it in this staircase, where the first number, 12 in this example, is on the inside and the second number, 3 in this example, is on the outside. The way we do this is by finding where in the 3's times table we can find 12. As we saw in the previous slide, 3 times 4 gives us 12. So we write 4 above the stair and write 12 below. Then we subtract to get the remainder, which is 0. 12 divided by 3 is 4, as we saw previously. We can do one more example to ingrain the organization of this method. So first we draw the stair and insert the first number inside and the second outside. So the 35 goes on the inside and the 5 stays on the outside. Now we need to find 35 in the table of 5. We can do this by listing the multiples of 5 until we reach 35. Then count to 35. We find that 35 is the 7th number, so we know that 5 times 7 is 35. We can add the 7 above the stair and we write 35 below. Subtracting it gives us a remainder of 0 and our final answer of 7. All the examples we've seen so far, except for the second one earlier in the video, has had a remainder of 0. Writing 2 remainder 1 is very drab and not easy on the eyes, so let's learn how we can write our remainders as fractions to make them look neater. Beginning with this first example, we set it up as usual, 17 on the inside and 3 on the outside. Now we need to find 17 in the table of 3. Since 3 times 5 is 15 and 3 times 6 is 18, we just missed 7 by 1. So we need to choose the lower one because we don't want a negative remainder. So we choose 3 times 5, which allows us to write 5 above and 15 below. Subtracting as normal, we get a remainder of 2. Now the answer is 5 remainder 2, because we can't continue dividing 2, right? Since 2 is smaller than 3. But instead of writing this answer as 5 remainder 2, we can write this as 5 2 over 3 as a mixed fraction, because we had a remainder of 2 and we were dividing by 3, so it becomes 2 over 3, like 2 divided by 3. So now we have a mixed fraction answer, all neat and tidy. Looking at the next one, we do the same thing. We put 24 on the inside of the stair, 5 on the outside, and try to find the number closest to 24. The closest numbers we can find are 5 times 4, which is 20, and 5 times 5, which is 25. Again, we missed the number by just 1, so we take the lower one. 5 times 4 gives us 20, we keep 4 above and 20 below. Subtracting as normal, we get a remainder of 4. we know that our answer is 4 remainder 4. But we can write this as 4 over 5, taking 4 as the remainder and putting it in a fraction above 5. For the last example, it's more of the same. 46 on the inside, 7 on the outside, finding a number closest to 46. The closest ones we can get are 7 times 6, which is 42, and 7 times 7, which is 49. Opting for the lower one, we take 7 times 6, 6 goes above, and 42 goes below 46. Subtracting it gives us a remainder of 4 yet again, and now we see that our final answer is 6 remainder 4. So we can write this as 6 4 over 7, because 4 is our remainder and 7 is our divisor. We need to remember that the remainder becomes the numerator and the divisor becomes the denominator. If you need to refresh on this terminology, you can check out the video in the card about different types of numbers. Now let's go over some practice questions. Take a minute and continue when you're ready. So starting with 24 divided by 6, we write 24 on the inside of the staircase, 6 on the outside. Try to find 24 in the table of 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. So we write 4 above, 24 below, subtract it, and we get a remainder of 0. So our final answer for 24 divided by 6 is 4. Going to the next question, we do 33 divided by 4. So we write this as usual, 33 on the inside, 4 on the outside. Finding a number that's closest to 33 in the table of 4, we find 4 times 8, which is 32, and 4 times 9, which is 36. Choosing the lower one, we take 8, throw it above, and write 32 below. When we subtract it, we get a remainder of 1. So rather than writing 8 remainder 1, we can write 8 1 over 4, because 1 is the remainder and 4 is the divisor. Going to the final question, 47 divided by 5, we write it as normal. 47 inside, 5 on the outside. Finding closest to 47, we find 5 times 9 is 45, and 5 times 10 is 50. So we take 45, throw 9 above, put the 45 below, and subtract. With a remainder of 2, we get our final answer as 9 remainder 2, or 9 2 over 5. Now let's look at division of larger numbers. It works the same as we have done previously, but we have the opportunity to break down the larger number into smaller parts. We can see this in action in the first example. Looking at this, we can try to divide 48 directly, but we could just take it one step at a time. We can start by looking at the first digit on the left side, which is 4 in this example. We know that we can get 4 by doing 2 times 2. So we write 2 above and write 4 below the 4 and subtract it to get a remainder of 0. Now that we have the remainder of 0, we can bring down the next digit, which is 8. Remember that this is only pulling one digit down at a time. So if there are more than one, it's only the next digit. So looking at 8, we know that we can get 8 in the table of 2 by doing 2 times 4. So we write 4 above, 8 below the 8, and subtract to get a remainder of 0, giving us a final answer of 24. Now let's look at a couple more examples. 63 divided by 4. We write 63 divided by 4 in the long addition form as normal. 63 inside, 4 on the outside. We know this by now. We look at 6 to begin with. Now the closest to 6 we can get in the table of 4 is 4. 4 times 1 is 4. So we write 1 above and 4 below. Subtracting it gives us a remainder of 2. Now bringing down the next digit, we get a new number of 23. So the closest number to 23 in the table of 4 is 20, which is 4 times 5. Writing 5 above and 20 below, we subtract it to get a remainder of 3, giving us a final answer of 15 remainder 3, or 15 3 over 4. One more example to cap it off, 87 divided by 7. Now we write it as normal, and we look at the first digit. We see it's 8. 8, the closest thing we can get in the table of 7 is 7. 7 times 1 is 7. We throw 1 above and 7 below the 8 and subtract. 8 minus 7 is 1. Bringing down the next digit makes the number 17. Closest to 17 in the table of 7 is 14, which is 7 times 2. We write 2 above, put 14 below, and subtract, and we get a final remainder of 3 yet again. So our final answer is 12 remainder 3, or 12 3 over 7. Now let's try some practice questions. Take a moment, continue when you're ready. Alright, so 63 divided by 3. We write it as normal, and start by looking at 6. We can find 6 in the table of 3 by 2. 3 times 2 gives us 6. 2 above, 6 below, we minus, we get 0. We bring down the 3 and our new number is 3. So 3 times 1 is 3. Pretty straightforward, we get our final answer of 21. Next up, 75 divided by 6. Looking at 7 first, the closest we can get is 6. 6 times 1 is 6. Writing that, subtracting gives us a remainder of 1. Bringing down the 5 gives us 15. The closest to 15 in the table of 6 is 6 times 2, which is 12. Writing 2 above and 12 below, we subtract to get a remainder of 3. And this leaves us with a final answer of 12 remainder 3, or 12 3 over 6, which can be simplified as 12 and a half. But we'll talk about that in another video. On to our final example, 84 divided by 8. The first number is 8, so we can do 8 times 1 giving us 8, subtracting it giving us 0. Bringing the 4 down, we get 4. Now with 4, we can't really do anything with it because 4 is smaller than 8 and there are no other numbers to bring down. So we have to do 8 times 0, subtracting 0 from the remainder, leaving us with a final remainder of 4. This is a simple trick to tell you that, okay, the answer can't be 1, so it has to have a 0. It has to be 10. So our final answer is 10 remainder 4, or 10 4 over 8, which can also be simplified as 10 and a half. Again, we'll talk about that in another video. Dividing so far has given us mixed fractions whenever we had a remainder, but we can also continue the division to get an answer in decimals. We saw this firsthand in the numbers video, the first video I ever uploaded, funnily enough. So let's have a look at that in more detail now. Looking at the first example, 6 divided by 4. When we do this, we know that 4 is the closest we can get to 6. Throwing 1 above, 4 below, we subtract to get a remainder of 2. Now, usually we can continue. So over here we would just write 1 and remainder 2, or 1 2 over 4. However, now that we're looking at decimals, we can do something about that. Whenever we add a decimal to the answer section at the top, we can add a 0 to our current remainder. So we add a decimal point next to the 1, allowing us to put a 0 next to the 2 below, making it 20. Now we know that we can find 20 in the table of 4 by doing 4 times 5. So we write 5 above and 20 below, subtracting it to get a final remainder of 0, giving us a total answer of 1.5. Let's do a couple more examples to really solidify this concept. 9 divided by 5. Setting it up as normal, we know that the closest number that we can get to 9 is 5. 5 times 1 is 5. So 1 above, 5 below, we get a remainder of 4. Now 4 is smaller than 5. We arrive at the same problem we did previously. So we add a decimal point above in the answer section and add a 0 in the remainder, making it 40. Now 40 can be found in the table of 5 by doing 5 times 8. So writing 8 above after the decimal point and 40 below, we can get a remainder of 0 after subtracting, giving us a final answer of 1.8. One more example before we do our last set of practice questions. 6 divided by 8. So looking at this, immediately we see that 6 is smaller than 8. So we do what we've done previously when this situation occurs. We add a decimal point in the answer section, allowing us to add a 0 which turns 6 into 60. Now the closest to 60 that we can get in the table of 8 is 8 times 7, which is 56. After that, it's 64, but we wouldn't take that because it's too big. Rolling with 8 times 7, we write 7 above and 56 below the 60, subtracting it to get a remainder of 4. Now with our new remainder, it's still smaller than 8, but it's not 0. So we can add another 0 next to it, turning it from 4 into 40. We can find 40 in the table of 8 by multiplying it with 5. So we write 5 above and 40 below, subtracting it to get a final remainder of 0. Now our answer below says 0.75. So we can fill in the gap on the left side by writing 0, making it 0.75. Now for our last set of practice questions. Take a moment, try it yourself, continue when you're ready. Okay, 10 divided by 4. We set it up as normal, 10 on the inside, 4 on the outside. The closest thing we can get to 10 is 8, which is 4 times 2. Writing the 2 above and the 8 below, we subtract it to get a remainder of 2. Now 2 is smaller than 4, so this is when we would add the decimal above and the 0 next to the 2, making it 20. Now 20 can be found in the table of 4 by doing 4 times 5. So writing 5 next to the decimal point and 20 below, we can subtract to get a final remainder of 0 and a final answer of 2.5. The next question is more of the same. 13 divided by 5, set up as normal. The closest we can get to 13 is 10, so we write 2 above, 10 below, and subtract, giving us a remainder of 3. Now, we arrive at the same problem. 3 is smaller than 5, so we add a decimal in the answer section and add a 0 next to the 3, making it 30. 30 can be found in the table of 5 by doing 5 times 6. So, writing 6 above and 30 below, we can subtract to get our final remainder of 0 and our final answer of 2.6. Going to the final question, we have 2 divided by 6. So, we set it up as normal. We see that 2 is smaller than 6, so we immediately start with a decimal point above to make the 2 into a 20. Now, the closest to 20 in the table of 6 is 18, which is 6 times 3. So I write 3 next to the decimal point above and 18 below. Subtracting it gives us a remainder of 2. Since 2 is still smaller than 6, we can add another 0 to the 2, making it 20 again. Now, we have to do 6 times 3 again, which puts 3 up in the answer's place and 18 below. Subtracting it gives us 2 again. So this is a phenomenon called the recurring decimal. Certain fractions are prone to have recurring numbers all the time. So in theory, the answer to this would be 0.33333333333333333, so many threes. All of the threes in existence, just all of the threes. You can fill up notebooks, you can fill up the whole universe with threes, and it would still not be enough threes. So the easiest way for mathematicians to denote this by adding a dot or a dash above the recurring decimal places. So over here, since 3 is the only recurring number, we write 0.3 and put a dot or a dash above it. I do the dot, if you do the dash, that's your business. In terms of notes, I'd repeat what I said at the end of the multiplication video. We need to know our times tables. It is critical. We should also know how to find multiples of larger tables like 13, for example. We can do that by continuous addition and noting down each answer as we go along. It's the same thing that we did for the table of 5 in one of the earlier examples. Practice is also a very important thing to keep in mind. Whenever you're learning a new method of answering a question, or just a new method of doing anything, it's important to practice. You don't become a baker after making one cake. Now we also see that writing remainders as fractions is a lot faster than writing them as decimals. So unless you're asked specifically to give your answer in decimals, always opt for fractions. Never waste your time in an exam. Time is so critical. And if you want to be able to sing through your exam papers, write in fractions unless you're asked specifically not to. We also learned about recurring decimals. These are shown with a dot or a dash above the digits that repeat in the number. Finally, I hadn't mentioned this earlier, but it was hinted to in one of the other questions. If you ever encounter a 0 that is brought down, we write a 0 above in the answer section and subtract 0 below, and then continue carrying down if there are additional numbers. This is to balance out the 0 being moved down. Since we drop it down, it's not yet a remainder. You can only get a remainder when you subtract something. So over here, you have to subtract 0. You can skip this step very easily at higher levels because nobody will look to see where the 0 came from, and they'll pretty much understand when looking at the question. Generally, when you come about this question as shown in the example here, you don't need to minus the 0. You can just take that 0 and plop it up on the top, making the answer 40. So that brings us to the end of the video. Thank you for watching, and I hope this video was of help to you. Take care, and I'll see you next time in the classroom.